Welcome to the Muscle Stimulation Virtual Laboratory. In this laboratory, we will investigate how increased workload affects a skeletal muscle's threshold of stimulation. In this investigation, you will explore the relationship between workload and a muscle's threshold of stimulation. You will determine the threshold stimulus for 4 different frog muscles: the thigh muscle, the calf muscle, the upper forelimb muscle, and the lower forelimb muscle, under workloads ranging from 0 grams to 80 grams. The objectives of this laboratory are as follows: to compare and contrast the threshold of stimulation for skeletal muscles under various workloads, to determine how a muscle's workload affects its threshold of stimulation, and to compare the points of muscle overload among various frog muscles. Let's look at some more information before we get started. How does increased workload affect a skeletal muscle's threshold of stimulation? 3 types of muscle tissues exist in the human body: cardiac muscle, smooth muscle, and skeletal muscle. Both cardiac and smooth muscles are called involuntary because their contractions cannot be consciously controlled. Cardiac muscle exists only in the heart and contracts approximately 70 times per minute to pump blood throughout a body's circulatory system. Smooth muscles line many internal organs, such as the trachea, intestines, and bladder. Smooth muscles contract and relax slowly, exerting and releasing pressure on the organs that they surround. Skeletal muscles are the muscles that are used for movement. They are called voluntary muscles because their contractions are consciously controlled. Skeletal muscles are attached to bones by bands of tissue called tendons and work in opposing pairs to move the bones of the skeleton. Skeletal muscle tissue is made up of individual cylindrical muscle cells called muscle fibers. When exposed to stimuli from the nervous system, each individual muscle fiber will contract either completely or not at all. This is known as the all or none law of skeletal muscle contraction. If enough individual fibers contract at one time, the entire muscle will contract. The strength of the muscle contraction is determined by the number of individual muscle fibers that respond to the stimulus. If a single, quick electrical stimulus is applied to a skeletal muscle, the muscle will respond by contracting and relaxing quickly. This type of quick contraction is called a muscle twitch. The weakest electrical stimulation required to cause a muscle to twitch is known as the muscle's threshold of stimulation. This value has been found to vary among different types of skeletal muscles and for a single muscle under varying workloads. As the workload on a muscle increases, the muscle will eventually reach a point at which it will no longer be able to contract, no matter how much electrical stimulation it receives. This is known as the point of muscle overload. Much of what biologists have learned about how skeletal muscles work has been discovered in the laboratory. The classic experiment modeled in this investigation involves isolating frog muscles and stimulating the muscles to observe their responses. The isolated muscle is attached to a ring stand that is wired to an oscilloscope. A stimulating electrode is clamped to the stand as well, with its tip resting on the muscle tissue. The oscilloscope is used to both generate stimuli of various voltage and to record the muscle's response to the stimulus as a twitch, indicated by a spike on the oscilloscope trace. To vary the amount of load on a muscle, small laboratory weights can be attached with a hook at the base of the muscle. To determine the muscle's threshold of stimulation under a specific workload, increasingly stronger stimuli are applied to the muscle via the stimulating electrode until a twitch is registered on the oscilloscope trace. Let's begin our experiment. We will begin by selecting a muscle by clicking the arrow under the word muscle. We can select lower forelimb, upper forelimb, calf, or thigh muscle. Let's begin with the lower forelimb muscle. You will see that the lower forelimb muscle has appeared. Next, we'll click on the up arrow on the oscilloscope, increasing the stimulus voltage to 0.5 volts. Let's apply this stimulus and see if anything happens to our muscle. Here we find that 0.5 volt stimulus was not enough to elicit a twitch. Let's increase our stimulus. We find here that in order to get a muscle twitch under no workload, this muscle requires 2.0 volts of stimulus. Let's record our data. Let's now place the 5-gram weight onto our muscle and find the threshold stimulus for this muscle with a 5-gram load. Here we see that with the 5-gram load, the stimulus threshold is 3 volts. Let's try this again with a 10-gram load. We continue increasing our stimulus voltage until we find the minimum stimulus required to elicit the muscle twitch. We find that the threshold stimulus for a muscle with the 10-gram force is 4.0 volts. Let's try our 20-gram weight. We see with the 20-gram weight, we have a threshold stimulus of 10 volts. Let's record our data. Let's apply the 40-gram load. We see with the 40-gram load that we cannot elicit the muscle twitch at the maximum voltage of 10 volts. Notice that the oscilloscope does not go any higher than this. We have reached the muscle overload. Let's make sure to record this in our data table. Let's reset our experiment and choose another muscle. Next, we'll look at the upper forelimb muscle. First, using no workload, let's apply the stimulus to get the threshold. We see that the threshold stimulus for the upper forelimb muscle with no load is 3. Let's record that data point. Let's repeat this experiment using the 5-gram weight. We will continue increasing the stimulus in order to find the minimum stimulus needed to elicit the muscle twitch. We find with the 5-gram load, we need a minimum of 4 volts in order to elicit the muscle twitch. Let's remove the 5-gram weight and add the 10-gram weight to our muscle. We'll continue applying the stimulus at stronger and stronger volts to find our threshold. The threshold for this muscle with the 10-gram load is 5. Let's remove the 10-gram weight and add the 20-gram weight. We'll continue increasing our stimulus. We see that we need a minimum voltage of 7 in order to elicit the muscle twitch with the 20-gram load. Next, let's try the 40-gram weight. We have reached the maximum stimulus and still have not caused the muscle to twitch. We must have reached the overload. Let's reset our experiment and try our next muscle. Next, we'll use the calf muscle. Let's find our threshold stimulus without any load on the muscle. We find the threshold stimulus for this muscle with no load is 5 volts. Let's begin adding weight to our muscle, starting with the 5 grams. We see that the threshold stimulus of this muscle with a 5-gram load is 5.5 volts. Let's try our next weight. With the 10-gram weight now in place, let's continue to increase our stimulus. We are able to see a twitch when we apply 6 volts with a load of 10 grams. Let's remove the 10-gram weight and add the 20-gram weight, and continue applying our stimulus. We see with the 20-gram weight, we need a minimum stimulus of 7 in order to elicit a muscle twitch. Let's try using the 40-gram weight. Here, we can elicit a muscle twitch by applying 8 volts of stimulus. Let's try the 80-gram weight. We have maxed out our oscilloscope and still have not seen a muscle twitch. Let's record our data. Here, we have reached the point of overload. We have one more muscle to try. Let's reset our experiment again and choose our final muscle. This time we choose the thigh muscle. Starting with no load, let's find our threshold stimulus. Our threshold stimulus for this thigh muscle with no load is 6 volts. Let's begin adding our weights. Starting with the 5-gram weight. We find that the minimum stimulus that needs to be applied to elicit a muscle twitch in this thigh muscle is 6.5 volts. Let's remove our 5-gram weight and place the 10-gram weight. Let's continue applying increasing voltage until we see a response. We see a response at 7 volts. Let's remove the 10-gram weight and add the 20-gram weight, and continue applying increasing amounts of stimulus. We find that the threshold stimulus for this muscle with the 20-gram load is 8 volts. Let's remove the 20-gram weight and add the 40-gram weight. Let's increase our stimulus to find the threshold. We find that the threshold for this muscle with the 40-gram load is 9 volts. We have one more data point to collect. We remove the 40-gram weight and add the 80-gram weight to our muscle. Let's continue applying and increasing the stimulus to see if we can get a muscle response. We see a muscle twitch when we apply 10 volts of stimulus. Great, now we have collected all of our data. Now, investigate and analyze your data so that you can be able to answer the following questions required for your lab write-up. I hope you enjoyed this presentation and happy investigating. Thank you for watching.